Hello there and welcome to a brand new video. This is Hub Beyond Numbers where we learn maths the easy way. In this video, we are looking at how to convert vectors from their column form to the magnitude bearing form. What do we need? You would need your graph and let me say your protractor and a pre-knowledge of how to find the magnitude of a vector, which was the video I did before this one. So if you haven't watched that, you can quickly go and then make some notes on that before coming here. So let's quickly go straight into it. Now, if you are given a vector in the column form, so let's say AB in the column form written as 4, 2, you see, and you are being asked to express it in the magnitude bearing form, how do we go about it? So the first thing you need to know, as I said earlier on, is how to find the magnitude of the vectors, because we said magnitude what? Bearing. So we first of all need to find the magnitude of this vector here. The magnitude of a vector, remembering the formula, we said for AB, magnitude of AB, which is written as this, is going to be x squared plus y squared, and then we find its square root. You see, so substituting into what we have here, it simply means the magnitude of AB is going to be a 4 squared plus a 2 squared, of which we find its square root. And we know 4 squared gives us a 16 plus 2 squared, which gives us a 4. If you have to evaluate this, we are going to get the square root of 20. You see, so the square root of 20, if you learned sets and then you want to simplify further, that is in form 3, then you are going to get what we have 2 root 5 units. You see, but at this stage you can choose to even leave it here and then write your units. It's fine. You see, so we have now gotten the magnitude of the vector. What we need now is the bearing. So to get the bearing, you go to your graph and then write out, or you are drawing using the components. You see, so that is on x it's 4 and then on y it's 2. So we come here and then draw that out, or we want a graphical representation of the vector. So from this point moving towards 4, but then 2 up. Okay, I think I did a mistake with the labeling. Let me just correct that quickly. Okay, so it says 4, 2. So starting from our origin, we get to 4 on the x-axis and move upwards by 2 on the y-axis. And that was AB. All right, that was AB. So it means it starts from A. You have your A here at the origin, and then your B is gonna be here. You see, this is the drawing, and we have already gotten the magnitude. So from here, we said the magnitude was what? 2 root 5, or let's just write the root 20 as it is, so root 20 units. But what is its angle? What is its angle? That is where you take your protractor and you measure this angle here. The angle it makes from, up here, we can see it's our north. So I'll take my protractor and then do that measurement. And we look at where this line passes through. So I'm just going to use an imaginary line to take note of that point. You see, it passes through here. For mine, I think that is a 75. Yes, that is a 75. It passes through 75 degrees. So we take note of that angle, and you can quickly come and write that down here. So I have my 75 degrees over here. And that helps me to get my magnitude and then direction. You see, so in this case now, we've been able to get our magnitude here, and we've been able to get our direction from this graph over here. So that simply implies that this vector over here, if we are to write it in magnitude bearing form, then first of all, we know its magnitude. That is what? Root 20 units, comma, its bearing 0.75 degrees. And that is all. All right, so I'm going over one last time. If you have the bearing, this is in its column form. You are being asked to write it in the magnitude direction form. You first of all solve for its magnitude using the formula of the magnitude of a vector. And that here gives us our magnitude. Now, if you're able to get your magnitude, then you graphically represent your vector to know the angle it makes from the north. If you're able to do that, that is all. You've gotten your magnitude and your bearing. Then you rewrite it in that form. So let's solve one last example. So this here is another question which says we should express UV, which is -3, in magnitude bearing form. So as we did for the previous one, you first need to find the magnitude of the vector. And how do you find the magnitude of a vector? So our U, then its magnitude is going to be the square root of x squared plus y squared, you see? And we know the value of x to be -3. So you have -3 all squared plus y, which is also -3 all squared. So we now evaluate. -3 squared gives us a 9. Then plus -3 squared also gives us a 9. So that gives us the square root of 9 plus 9, which is 18. You see? So the square root of 18, you can leave it this way. But in form 3, if you understand sets, you realize that this here is going to give you 3 root 2, right? So units. So you can either leave it this way or you leave it this way. So now that we've been able to write the magnitude, we now go to our graph and then try and plot out our -3, -3. So using my arrow, I believe my -3, -3. So we say on x, let us move towards -3. So this is my -3. And then let's come down to -3 on the y. So this is down here. And this will be my point, you see, and that is u v. So I'm going to put my u here, and then my v is going to be here. Now we are left with the angle, you see. So from the north, what angle does all of this cover? You can quickly take your protractor and measure that. Now we do know that an angle on a straight line is 180. So this angle here on the straight line is 180 degrees. So all we need is this small side to add to the 180 degrees. So we can take our protractor and then measure the angle of this small side over here. So this is my protractor, and I'm going to measure this small angle over here. Now if you look at it carefully, you realize that it passes through my 45 degree. If I'm to use dotted line to trace that out, you see where it passes through. We are starting, I am using my inner calibration because that is where I have my 0. So 0, then I have my 10 somewhere around here, 20, 30, 40, and 45. So that angle I am looking for is a 45-degree angle. So I put my 45-degree here. And as I said earlier on, this angle on a straight line is 180. So the whole of this angle is a 180 plus a 45 degrees. It simply means that this we have over here, that is UV, which was -3, -3, in magnitude bearing form is going to be what? What was its magnitude? That was root 18 or 3 root 2. You see? So 3 root 2 units. And then its bearing being what? 225 degrees. And you are done. You see? So this is how we write vectors from their column form into what? Magnitude bearing forms. So I'll be writing out some exercise which you can try your hands on. If there is something you do not understand, you can just go back to the video and then play it slowly, and I do hope that you would get the concept. So this here is a trial question. It says you should express the following column vectors as magnitude bearing forms: 3, 6, -3, 4, and then you have 0, 4. Try your hands on this and then let me know your feedback. This is Hub Beyond Numbers. If this is your first time, you can choose to subscribe so that anytime I release math related video, you'll be notified and then you can learn along as well. Thanks for staying and then have a blessed day. Bye.